Hey folks, welcome to today's lesson where we're going to be talking about speed and velocity. These are sort of extensions of what we did last lesson, which was looking at distance and displacement. We'll start off with speed. Speed is something that we're all pretty familiar with. If you increase the speed of a car, you're going to go faster. If you slow it down, it'll go slower. Speed is a scalar quantity, which, as a reminder, has magnitude only. I'm just going to write mag for short because I reckon we're probably starting to get an understanding of what this means. And we could say, as an example, 10 meters per second. Now, 10 meters per second means I'm moving every second, I'm moving 10 meters forwards. Okay, and we know it's a scalar quantity because there's no mention of direction there. If there was a direction, we would be talking about velocity, which I'll talk about later. Let's break down a few of these things here. So this 10, okay, represents the magnitude here, and we've got these units which we can break down. So the meters here means we've got a distance here, and our seconds means we've got a time. And we'll get pretty, I guess, we will try and be a little bit fanatical about our units. It will make sense as we get a bit further on. I'm just going to stress this. Now this dash, I said it's called a per. So I say 10 meters per second. It also really means divide. That's actually what it represents. It means there's a division going on there. It's explaining a relationship between a magnitude and a time. Well, they're both really magnitudes. That's not really the right way of putting it. It's two different units of two different quantities that's explaining a relationship. And if we were to break that down as an equation, speed equals distance divided by time. And I could write this for short. I could go as a fraction, d over t. Right? And just remember that these represent our little units there, meters per second. You could also have kilometers per hour, light years per year, or no, that doesn't make sense. Oh, something like that. How fast does light travel in a year? That sort of thing. Okay. Now, if we were going to do an equation with this, let's say that I want to know an object has moved 30 meters in 5 seconds. What is their speed? Or its speed, I should say. Object, whatever. 30 meters in 5 seconds. Now, you could intuitively do this, and I suggest that if you're ever having problems understanding these equations or anything like that, sometimes it's worthwhile putting yourself in reality and imagining like, okay, this object has covered 30 meters in 5 seconds. So as each second passes, something is happening. All we have to do is we can plug it in. So speed, and I'm not going to write s because that'll get a bit confusing if we're using seconds and stuff. Speed equals 30 divided by 5, which equals 6 meters per second. Okay? 6 meters per second. Make sure that you got that unit. Now, if this was, I'm not recommending that you do it for this problem because it's pretty easy, but if it was a bit tricky and you say you're in a test condition or an exam or something like that, and you're like, oh, have I got it right? Well, redo it. Do it the other way. Let's say I'm going 6 meters per second for 5 seconds, right? What is the total distance that you travel in those 5 seconds? So you go 6, 12, 18, 24, 30. Each spot was a second there. So we've reversed it, so 6 times 5, which equals 30 meters. I've got 30 meters, I can check it against there. Things are pretty good. It's a really good approach for when your problems are a little bit more difficult, and as I said, if you're not super confident with your original answer. Alright, so the last part that we're going to look at is velocity. And velocity is a vector quantity, vector q, which means it has magnitude and direction. Okay, mag and direction. So an example of this would be 30 kilometers per hour north. We've got our direction here. We have our magnitude here as well. Now let's just break a few things down. We have our time still. Now I've written hour there. When I was talking about speed, it was seconds. This is irrelevant. Doesn't change it between a vector or scalar. Hour is just a different unit of time. You could turn hours into seconds anyway. It's the same sort of thing. Kilometer, we have, I'll come to a kilometer in a second actually. We'll do the division sign here. That's the per. Now kilometer, when it was speed, we said the meters or the kilometers, this unit, that was a measure of distance. For velocity, it's not just a distance or a magnitude that we're looking at, it has a direction. So in this case, it's going to be displacement here, right? Because it has a magnitude, the 30, and it has a direction. So in this case, our formula for velocity, and velocity will always be shortened to v. Speed is never s, because we just don't use speed that often. S is reserved for seconds, but velocity equals displacement over time. The change of displacement over time. And we would shorten that to d over t. If we were being like a bit finicky, d will always, if you ever see d in an equation or something like that, it's going to mean displacement. So it means there's a direction there. It's not going to be distance. So hopefully that, like, I don't know, it doesn't confuse you too much. So let's say, like, okay, how far do they travel, or does it travel in let's not do 3 seconds. Let's go, let's say in I'm going to be a bit sneaky. We'll say 15 seconds. So what would move 30 kilometers an hour? A really slow car, okay? It's just driving in, so you're in a car, it's driving in the suburbs or something like that, you know, that maybe coming towards your house, it's going to sort of park. It's traveling slow, it's going to travel in about 15 seconds. How far does it travel in those 15 seconds? So there's a couple of things that we have to sort out, because it can be very tempting to say, well, if it travels in 15 seconds, we would say our velocity, which is 30 kilometers an hour, times our 15 seconds, that's our time, that will equal our total displacement. And 30 times 15, what is that, 300, 450. So you would have something like, our displacement was 450 kilometers. Now, that's a bit of a noob error, okay? Something is not right here. You can't travel in a car at 30 kilometers an hour and move in 450 kilometers in 15 seconds. This does not make sense. There is something terribly wrong with this. And the reason is because our units are incorrect. We have tried to use seconds here when the original format was in hours, okay? So what we really need to do first of all is we need to turn this 30 kilometers an hour into our meters per second, okay? Now, how do we do that? The first step is, I might start it up here, 30 kilometers an hour. Now, if I was going to turn this into meters per hour, so we'll leave the time the same for the moment. How many meters are there in a kilometer? There's going to be 1,000. So what we need to do is we need to times this by 1,000. So in this case, we're going to have a speed of, a velocity of 30,000 meters an hour. All right. The next thing that we need to do is we need to convert that into meters per second. How many seconds are there in an hour? there is 60 minutes in an hour, and there's 60 seconds in each minute. So we need to divide by 60, and then we need to divide by 60 again. Overall, that comes to dividing by 3,600. Okay. So just bring up my calculator here. 30,000 divided by 60. I'll do it the short way. Divided by 60. And we've got a distance of 8.3 meters per second, which is pretty fast still. You can still do a lot of damage with that. Like that's far faster than someone who's walking. Like someone who walks would do max like 5 kilometers an hour, which would be, you know, a sixth of that. So it's about 2 meters a second. Now that's the first step. We've done this translation. Now what we need to do is we need to answer this question. Well, how far does it travel in 15 seconds? So I'm just going to highlight this green so you know where I'm getting it from. The 8.3 meters per second is our velocity. And I'll have the units here just to help you folks out. You don't have to have units when you're working out, just the final answer. But 8.3 meters per second times by 15, and that's going to be times by 15, 125. So we've got 125 meters. That should be seconds, which makes a lot more sense than 450 kilometers, which was ridiculous. It's a complete nonsense. So that is the difference of velocity compared to speed, but also a couple of ideas on how to translate or transform 30 kilometers per hour into meters per second. Now, if you wanted to do it the other way, so say I wanted to go meters per second into meters per hour, we just do the reverse of what we've done here. So we would just times by 3,600, and then here we're going to divide by 1,000. Now, if converting units is not like your thing, don't stress too much. Like there'll be a question on the test or something. It's not going to be the end all, but it is a good approach just to sort of, if you are struggling, break it down step by step. If you're super confident, you can do a little bit of a shortcut if you can memorize it, and that would be, we can just skip one whole step. Instead of doing that and then that, we'll combine them, and it's just going to be times by 3.6. 8.3 times by 3.6 equals 30, and we could go the other way. Whoops, I'm going to be drawing all over my work. We could divide by 3.6. 30 divided by 3.6 equals 8.3. So that's a quick shortcut if you want to. But if you're not comfortable with that, break it down. Make it easy for you. Other than that, your work that you're going to have to do today is, first of all, classify things as either speed or velocity. The second thing is you're going to have to compare them. But then with the equations, the calculations, there'll be a couple of problems that you'll have to do. The first one should be pretty tame. They should be sort of the ones that we did previously. But then the later ones, you'll need to do some conversions. It's always really important to just double check the units. Just make sure that the units are there and have a bit of working out. Check your answer. If it's wacky, if it doesn't make sense, it's probably because you haven't got the units right. The thing is, units are not just going to crop up in this. When we talk about energy transformations or even forces, we're going to have to change the unit sometimes as well to cater for that. So it's just something to keep your eye out on. All right, peace out.